Okay, so this is for differential equation students. We're going to be talking about a technique called reduction of order. Okay, so let's say we're given the differential equation. We have x squared, y double prime, okay, plus 3x, y tick, plus y equals 0. So second order DE, it's got non-constant coefficients, it's homogeneous, and you're also given a solution. So reduction of order is useful when you have a second order DE that you're going to solve, but you're afforded that one solution will say y is equal to, it's technically cx to the negative 1, but I'm just going to call it x to the negative 1 for now. We'll put the constant back in when we need it at the end here. Okay, so you have to understand, like a lot of times people spend a lot of time solving equations like this. This one is called a Cauchy-Euler equation. Okay, so it's not unreasonable to think that somebody might come up with a solution to a differential equation, and then you need two because it's second order. Like, well, how do you get the second one? So what we're going to do is we're going to assume that our first one is good, verify that. Okay. But what we're going to do is we're going to say that our y2 is equal to some function, which I'm just going to call u, times our first function, x to the negative 1. Okay, so such that this is not a linear combination, right? That u is not a constant. Okay, u is some other function of x, and we're going to multiply it by the first function. They're not going to be linearly dependent. Okay, so that's going to be two linearly independent functions, and we can verify that with a Wronskian and all sorts of other fun stuff. So our next step here, okay, so this is our first thing. Okay, we've assumed a new solution. Two, we're going to take a lot of derivatives. So y2, right, is equal to this guy here. So our first derivative is equal to derivative of the first times the second, okay, plus the first times the derivative of the second. Can't put the minus in there because it's going to be negative what's going to come down in front. Okay. Our third step here, keep taking derivatives. Okay. Y2 double tick. Okay, now we've got to take derivative of this piece. So again, we have more product rules. Okay. So derivative of the first, which is going to be u double tick y to x to the negative 1. Okay, derivative of the first times the second plus the first times the derivative of the second. Okay, so that's this piece here. Okay, the next piece is now we have to take the derivative of this part, right? So we're going to have a minus derivative of the first, u tick times the second. Okay, and then the first times the derivative of the second. That's where the negative 2 came down, so we have a x to the negative 3 here. Okay, so that's my second derivative of y. All right. So what we're going to do now is we're going to insert this into our original problem. Okay, we were given an original problem here, so what we're going to do is we're going to call it I. We could plug our two solutions into I. Okay, so what we're going to have here is x squared times what? Times our second derivative here. So that's going to be u double prime x to the negative 1 minus, actually there's two of these, right? There's one here, there's one here. So we're going to have minus 2 u ticks x to the negative 2 plus 2 u x to the negative 3. Okay, so that's our first piece there. Okay, then we have plus 3x. Okay, plus 3x. What is our first derivative? First derivative is u tick x to the negative 1 minus u x to the minus 2. Right, that's the second piece of our original problem. And then we're going to add in our y. Okay, so we're going to say this is y1 times u. So this is u x to the minus 1. And what was this equal to? Okay, going back up here is homogeneous solution, so we are going to have equals 0. And now what we're going to do is we're going to do a little bit of algebra. Okay, so mostly this is always going to work out the same way. Okay, we're doing the algebra as a check to make sure that we did everything right. Okay, so we're going to have u double prime, okay, x squared times x to the negative 1. That's just going to be an x here. We have a minus 2u tick. X squared times x to the negative 2 is just going to be 0. Well, x to the 0. And then we're going to have a plus 2u, and then we just have an x to the negative 1 here. Okay, now we have to distribute. So we have 3x times this piece here. So it's going to be 3u tick. Okay, the x to the negative 1 times the x is going to be x to the 0. It's going to go away. Minus, and then we have 3u. Let's go with this, erase. Okay, I want 3u. This x is going to turn this into x to the minus 1. And then we're going to have plus u x to the minus 1 equals this 0 here. Okay. So a couple of things I'd like to draw your attention to. By the way, this is going to work out pretty much the same way for every one of these. Okay. So I've got, let's see, did I make sure I have my signs in here? I did not. So that's a thing. Let's double check to make sure that we cleared our signs correctly. Okay, that's always the case here. So when I multiply this through, we're going to have a minus 3. So it's going to change to a minus. So we're going to have a minus. So we have, oh, that was okay. There we go. That was good. We're okay. That was this one here. Okay, I was looking at the wrong piece. So here we have, go back to my colored pen here. So we've got a u x to the negative 1 here, a u x to the negative 1 here, and we have 3 u x to the negative 1s. Okay, so we have 2 plus 1 is 3 of these, minus 3 of these. So these are all going to cancel off. Okay, this is going to work every time you've got one of these. Okay, it's always going to turn out this way. If it doesn't, check your algebra, check your calculus to make sure you took the derivatives correctly. If those pesky signs are going to get us every time. Okay, so what are we left with? We have u double prime x, that's this piece here, minus, we've got negative 2 of these, plus 3 of these. So it's going to be plus u tick, right? And then all of this other stuff cancels. It's always going to happen. Okay, and this is equal to 0. Now, look at this. We could say w tick, or w equals u tick. Okay, w equals u tick. So w tick would equal u double tick. Okay. So notice we have u double tick here. So we have x, keep that x there. U double tick is now w1 tick plus what's u tick? It's just w equals 0. Now, would you look at that? That looks like a first order linear DE to me. Okay. And we need to get an integration factor. Remember, you got to clean this thing off. So this is going to be w tick plus 1 over x. W equals 0. And now we're going to get our integration factor. So integration factor is e to the integral 1 over x dx. Okay, so this is going to be e to the ln x, which is just going to be x. Okay, so what I'm going to do is I'm just going to multiply everybody here through x. So we're going to have x w tick plus w equals, what happens to the right-hand side? It's just 0. So what we're going to do is we're going to say, hey, we know how to take the the antiderivative of this. So this is going to be the derivative of xw equals 0. We can integrate both sides. Okay, so we're going to have xw equals a constant. Okay, or okay, w equals some kind of a constant over x. What was w again? W was u tick equals c over x. Now we have to integrate this guy. Okay, so this is going to be u is equal to c. Now we have to integrate this guy here. That's just going to be ln x. Okay, plus c2. Okay, c1 ln x c2. Okay, and now going back to resubstitute way back at the beginning, right? We had y2 was equal to u y1. Well, what was y1? Y1 was x to the negative 1. So c2 is equal to c1 ln x plus c2, and then my y1 was x to the negative 1. So my y2 is equal to c1 over x times ln x plus c2 x to the minus 1. Do you remember what my first solution was? Right? My first solution that was given by 1 was equal to x to the negative 1. I said we'll take out the constant and get it back when we need it. Now is that time. Okay, so this is going to be my second solution, all right, to this second order differential equation. So here are my two solutions that we have now generated. Okay, we don't really need this one because we have this is a linear combination here. So we're just going to say y is equal to c1 ln x over x plus c2 over x. Okay, and those are my two independent solutions, and that's how you do reduction of order. Okay, so thank you for tuning in, and I will see you in another video.